Hi everyone. Today we'll look at user-defined exception. The exceptions are, many exceptions are already defined. Okay, so that we can simply use it. But in the real world, and depending upon the applications, all the exceptions, it is impossible to define all the exceptions predefined. So as you develop the real world examples, then you may need quite a few exceptions that you have to define. We call that user-defined exceptions. Excuse me. We looked at the built-in exceptions. If you click this, then I think it is all gone. User-defined exceptions, then it comes here. This is the case that you define a dictionary. Let's say here, a Python code to create a dictionary of employees and monthly pay pair, so employee and monthly pay. So there is a key and amount for given employee listed. Assuming the range of employees monthly pay. For each employees, the monthly pay is interactively received. Only if a given salary is in the permitted range, the employees and salary pair can be stored in a dictionary. So we can say the amount is greater than 1,000 and less than 9,000. Then we can put that in a dictionary. Otherwise, we can say error. Okay. Excuse me. Okay, I'm back. I think I got a cold. that is reason. All right. So assuming the above function makes sense and run the below this code. So employees, the list of employees, and this month pay that is empty, a dictionary, and for the employees, and then we can ask user to enter monthly pay. So you can say, for example, Chris, then 1,200. It says name the error. What is this? This month dictionary. This month's pay. Monthly pay. I think this is my error. What happens? This month pay equals we have to run this first. Okay, that runs, and then so 1,200. Then Chris has 12, and Bob, let's say 8,900. Big money, and then David 5,500. And who else? Jason, maybe 900. It's give us an error because it doesn't meet this range, right? And Jensen Huang, NVIDIA, then he receives that much money. So that also error. So this kind of things that you can handle, right? So this guy handles this function, handles and without having any errors, simply return the messages so that we have that. So this kind of errors that you could handle like this, or errors that may halt your system, so system does not run anymore, it stops. So all kinds of errors needs to be handled. So in logic, your program needs to run legally, and in system environment, your program should run. If there is an error, then your program needs to handle the error, so to avoid any system halt. That type of things is exception handling. But some of the exceptions that you want to handle is not really defined by the systems like this. This kind of the salary range is not really defined, right? So that type of exception is called user-defined exceptions. So user-defined exceptions, usually you have to define a class, where actually in object orientation, your exception is a subclass of the exception that's already defined. I believe, yeah. This is the exceptions, base exceptions. And under there are several other exceptions. One of them is error. So the user-defined, those are the exceptions already defined, right? They are hierarchically organized. So all the exceptions you see here, stop iteration exception, arithmetic exceptions, attribute error exception, end of file exceptions, memory exceptions, name errors, runtime error, type error, warning, recursion error, and much more, right? So when you define in, because this is an object orientation paradigm, everything should be organized hierarchically. So when you define your exception, then exception should be under this hierarchical structure. If you say, my exception is a subclass of a base exception, then your exception plugged in this right below base exception. But if you say, hey, my exception is a subclass of exception, then your class will be here. If you say, hey, my class is a syntax error, then your exception will be the subclass of this syntax error. So in this case, pay range, I would say base exception. Then it'll be on top, right? Pay range will be somewhere here. Pay range. Okay. And then I have a similar of those things. You can say monthly pay is less than 1,000. You can say a lower bound of 1,000. If it is greater than 9,000, you can, greater than 1,000 and less than 9,000, then it runs as is. And if it is above 9,000, then exception handlers needs to be in this the clause. We call that try and exception clause. Try and exception. In try block, you need to raise exception because this is a user defined. So your system does not know. So you have to raise it, raise the exception. If some exceptions, if it is built in, then your system knows when the system needs to raise the exceptions, right? Because of this is user defined, so you have to manually raise that exception if that out of that permitted range. Okay, so we have here range raised exception and other exceptions. So if you run this, then say 99, 900, then pair is not defined, right? Does it work? It does not work, right? So what we need to do here is we have to do here basic exception. So we say if we have exception A and exception B, and top error, which is right below basic exception, and then under this error we have exception A. It says exception A is a subclass of error, right? Exception B is a subclass of error also. So we can raise that, and then we do here based on this event. So event is A, then we raise exception A. Event calls B, then we raise exception B. Other than that, nothing happened. So we have a try block and exception because we raised two different types of exceptions. So except the exception A as this is a variable, and then we print the exception E. So we need to go back to see what is the exception A, definition of exception A. If you come here, exception A, then it's nothing. We just pass, right? Nothing. So let's try. So this is a hierarchical of the exception definition, and then we raise such exceptions. Like here, if we say A, then A is selected, and if it is B, then B is selected as it is said. And if we say here, let's say C, then it's nothing happens. So we say nothing happens, right? So we raise it that way. So what happens here is actually, let's see if we have some of the better exceptions, or not really better exceptions here. So what I will do, I'm going to revise this a little bit, saying in this exception, rather than pass, I want to define a function, init function. That init function has a self object, self variable, and then let's say I have messages. Then self dot messages will be assigned by that messages. Okay, and then if we say another exception, say def and string exception, this string exception will be activated when the self object is invoked. So we can say return, or we simply say print what I want to print is a self message. Okay. This is my definition for that exception. So exception A is defined that way, and exception B, I would define exception a little different. This is okay, but when the self, rather than print, I simply return. Return, and then self messages, and then we can do more from exception B, dot, dot, dot. We simply that way, okay? So we execute that, and when we do this, if I say, what is the event? If I say D is not there, right? Say nothing happens. But if we do, for example, A, then this guy says if it is A, then print E. E is, what happens here is when you say E, this is an object, right? E is an object of exception A. If I say this is E1, so E1 for exception A, E2 is an object of exception B, so I can say here 2. And even if I don't do anything here, for example, pass, still this guy says, when I do A, then it, when I say A, then if I say 1, A, let's say here, A, we have a print, right? So if I call it, then it should say E1. This is an object. When I call object, when I do print E1, when I say A, string returns non-string type. E1, right, because I put there print statements. So if we, like here, I may need to return, right? So rather than this, return, simply return it. And I want to run this first. And when I came here, run. And then when I say A, then A is selected. So this A is selected message is when here the exception A is raised, then it calls exception A class by receiving message. That message is assigned to self message. So this exception A has a field message. We call the self.message, and that self.message is returned. So when this was raised, this statement goes up. So whatever the message is. So say, hey, A, there is an accident A. for example. Then when I say A, then it says, hey, there is an accident A. Why that happens? Because this is a message. That message is plugged in to self.message, and here in my program, so when this is raised, okay, so we try, and this is done, and the next statement is here, except, and then there is a exception. A object is available, then we print that object E1. That object E1 returned by here. When object is called, then string is returned, which is self messages. All right. So message that received here, that is returned back. You can return more than that, like here. So for example, when I run this, and then I said B, then this guy is raised with, for the exception B, then here is the definition of exception B. It was initialized by assigning that message to self.message. And when that object is called, then we want to return the message that we received plus from B and 3 exclamations mark, like this. B is selected from exception B. So you can do, in this try block, you can either raise the exceptions or handle whatever that it is needed. So for example, nothing happened. This is the main part of this program. The other two, this is the exceptional case. If the exception takes place, then come here, exception block, then that exception is handled. The first exception block handles exception A. Second exception block handles exception B. The way it handles here, simply print that object. All right. If we say here, for example, I want to send this with, for example, let's say, if I have a import time and then print time dot c time, this is the current time. So I'm going to use here, okay? So here, import time. I'm going to send here time dot c time, calendar time. So when I raise this exception, I want to send 2 arguments. Then here we need to say 2 arguments, not only message, but I would say timestamp, TS. And then I can say self dot timestamp equals TS. And then I would say this is what? Hey, there is an accident A. And then we can say, okay, so this much that we do. So we execute this, and then here, the way that I can accept here, I want to say print E1 dot timestamps. because timestamps that we have. And we can say here and equals and at that time. Okay. So I want to save this and run. So let's say A occurs. Then it says, hey, there is an accident A at this time. So when I have here one more space, then when I do A, then hey, there is an accident A at Friday, October, whatever that, okay? So that's what, how, this is the way of handling that exception. The other one is the other way, it's different handlings, right? Yeah, so this is exception handlings. So nested is possible. So there is a some of the examples. I want you to practice it. And homework assignments here, I think we have 2 homework assignments. Use a nested exception handling. So enter your membership type. If we say super, then warning, your membership is in the blacklist. No service is provided to this membership. If you say super. And the other one is, so enter your membership type, silver. Then what do you want? Transfer, deposit. Then how much do you want to transfer? 20, then insufficient amount of chosen, and so on and so forth. So so you need to declare the exceptions. So I want you to put here defining exceptions. And then this is the main program. Okay. So most of the code here. When you run this exception, which means define the exception, and then run this program, and then there is a raise somewhere that in your code you have to raise the exceptions, and therefore you may have this kind of output, right? This is homework number 1. The other homework here, homework number 2, I want you to recall the submission policy of your homeworks. So there is a late penalties, right? Late submission is allowed at longest 7 days. If you submit later than 7 days, then you will receive 0 credits. Up to this 7 days, then each day there is a 10% off, cut the points off, right? So, and also there will be one time late submission allowed if you want to, all right? So, for example, the given list of students here, dictionary, John has 0 time late submission redemption. Sam has already 1 time submission redemption. Alice has 1 time, and Bob and Peter has also 1 time. And then the initial grade for Sam, 90, but he has a 3-day late submission. John, the grading as is without considering late submission, 88 points, but on time submission. Alice received 77, but 7 days late submission. Bob, 75 points on, but 9 days late submission. Therefore, for example, Bob Bob's grade originally 75, but actually earned 0 because no credit due to significant late submissions. Okay. And Sam here, for example, Sam originally received 90, but actually earned 62,999 because he had 3 days late penalties. So that type of things is returned based upon the student list. Here, Peter didn't submit. If you see this first grade, right? Therefore, Peter did not submit the homeworks. Peter earns 0 credit absolutely, right? There's no submissions. That needs to be done, but I gave you the templates. Actually, maybe 4 the class definition of exceptions, starting with the my exception, which is a subclass of exception. All other exceptions are subclasses from my exception. So I have no submission student exception, late penalty exception, and then redemption exceptions. Okay, so actually this no submission exceptions, we initialize that and get the name. So we entered the name, self.name equals name. And then string is, we simply say, did not submit homework assignments. If this exception is raised, then we can say when this exception is raised, we need to go back to our main code here and say this grading, we get the name. We first try if name is in the first grade dot keys. See your first grade? First grade is this, right? If name, say Peter is in this key among this first grade dictionary, then definitely we say he didn't submit, right? That we need to first check. So here, if given name is in that keys list, then we handle. Other than that, then here final here, else, then we raise no submission student. And we raise this exception with the parameter name to send. So we pass this name. Then that name comes into this class, and name is set to self.name, and we return that name here. So that name did not submit the homework, right? And other than that, then we take the number of days, number of the late days, latency of the days, and then grade from the first grade dictionary for given name. And then we print the originally this guy received that grade. So this is as it is given, which means as it is given here, right? For each given names. And then once it is ready, then we try. So we have a try and exception. So we have 2 except here. If the first grade, if this is a 0, what that means is that it's an on-time submission. On-time submission, then we need to and redemption, on-time submission, this is not really, logically, doesn't really make sense, but let's say as is, okay? We could change this, but let's say if it's on time, still we can get some redemption. What is this? Oh, number one. Oh, this is this. If there is a oh, this is the first grade and number one, the number of delays. This is a 0 delays. A little bit of awkward. Okay. We actually need to do, in reality, if it is a 0, then we don't need to do, right? If it is not 0, then we need to raise redemption. I think that is a better way. It's a little bit of you have to massage a little bit over here. So we raise redemption. We raise late penalty. If the way that we can redemption is if anyone has not used yet late submission waiver redemption, then we can use it. And otherwise, definitely there is a late penalties. So a little bit of a massage here. I want to ask you to do that. Okay. After we try this, then we need to handle the exception. In the case of a redemption, in the case of a late penalties, some of those. Okay, so we will have this kind of things. Okay. So you have to feel this. Your code here. Everything about here, your code, then you have to fill in here, okay? Only that. As I said here, one thing that you have to be aware, you must use the template below. If you do not follow the template below, you will get 50% penalties. Why I do this? Because this is OpenAI is bad guy. It's not really bad guy. He's a good guy, right? But for a class, yeah, it could be a bad guy. So when I grade the students' grade, some students' coding is really, really nice. It's like professional grading. I can tell, oh, this may be helped by AI coder. So when you graduate, after you graduate, and if you are working for a project, then you could get help from AI. Definitely, that's you need to take benefit from AI assistance. But in order to learn something, we need to learn more, right? So I want you to practice. If I say this explicitly, then don't do. Simply try to use the code that templates that I give it to you, okay? So you need to practice this and submit only Python code, okay? the way that you could do is you need to open new collab, and then simply you can copy this whole thing, right? You simply do here, copy cell, and come back here, and then paste. And then you need to work. This is only Python code. So you can simply just submit this, right? As you do here, download PY. Once you complete this, then download the PY and submit it. All right, that's what I ask you to do. I'm going to stop here. Thank you.